lecture, we will going to talk about the BCD codes.
Let me talk about the BCD codes. BCD stands for the binary codes. Whenever we are talking about the digital system, we can say that we have only got a two distance values. That means we are talking about either 0 or 1. And even if we are talking about the stability of a system, that the stable system can be stable in the two state. Either it can have a 0 or it can have a 1 value. So in that case, what we are using, we will use a BCD, binary code decimal, to represent our decimal equivalent. Name is also important, binary coded decimal. And finally, I am writing a word code. Okay, so this is the BCD code. So what we are doing, whatever the decimal number we have got, we will going to represent it. For example, if I have got a decimal number 396, so I can use a binary code to represent this number. So first we have to understand what is the BCD. So in decimal, when we are talking about the decimal, how many number I can represent? 0 to 9. That means if I talk about 9, we have got 0 to 9. If I want to represent this 9, how I can represent? 1001. That means when we are talking about binary coded decimal, so we have got 0 to 9 only. And let me write the decimal symbol here, and I am writing a decimal equivalent of it. So I am writing a BCD digit for it. BCD digit for it. So I know that the decimal equivalent which I am taking here is either I have got starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I write the equivalent of it, okay, so you can see that for 0 what I have to write, for 9, for 4, let's say I will take some random samples. Okay, so for 0 what I will going to write, I have to write 0 0 0 0. For 2 what I have to write 0 0 1 0. Okay, for 4 what I have to write 0 1 0 0. For 7 what I have to write 0 1 1 1. Okay, for 9 what I have to write 1 0 0 1. Is it clear? So I can complete, because I don't want to write all the things, because you know how to complete. So 1 can be written as 0 0 1. So we have got a decimal symbol and we have got a BCD digit for it. Okay, so how we can represent the binary coded decimal? So if I have got this 396, I have to represent 396 in a binary coded decimal. What I have to do? I have to use a 3. For 3 what I have to use? 0 0 1 1. For 9 what I have to use? 1 0 0 1. And for 6 what I have to use? 0 1 1 0. So it will going to represent your BCD. So what we are trying to do is that the 4-bit of a group. So 4-bit groups. This 4-bit groups will going to represent your 1 decimal. Your 4-bit groups will going to represent your 1 decimal equivalent. So let's say if we have to add two numbers. So how we will going to add these two numbers? So let me take another example. Let's say I have to add a 4 plus 5. 4 plus 5 in BCD. What will be my answer? 4 plus 5 is your 9. And even if I perform this operation, I perform a simple operation on this 9. Even if I take this one, I can do 4. What is the 4? 0 1 0 0. And what is 5? 5 is your this. And if I perform this addition of this, so can you tell me what will be the answer? The answer will be 1 0 0 1. Now take another example. Now in this example, what I have to do, I have to add 4 plus 8. So what will be my answer? My answer will be 12. So let's take 4. What will be the equivalent of this 4? 0 1 0 0. And what is the equivalent of 8? 1 0 0 0. Add these two numbers. What you will going to get? You will going to get 1 1 0 0. 1 1 0 0. So what is 1 1 0 0? 1 1 0 0 is 12. But in decimal BCD, we do not have a 12. Okay, we have only a symbols of a starting from 0 to 9. We do not have a 12. So you can see that we don't have a number of a 12 in a BCD. We have a number only from 0 to 9. Apart from this, what you can see that we have got a number which can come as a 10, A, B, C, D, E. These are the extra number which we have got. So if we count this, what will be my number? Total number will be a 6. What will happen? I have got a additional numbers which has close to the 6. So whatever the answer which we are getting, if we want to make it a BCD equivalent, what we will do? We will going to add the equivalent of a 6 in it. Okay, so I will going to add a equivalent of a 6 in it. So what will be the 6? The equivalent of a 6 will be your 0, 1, 1, 0. So I will going to add 6 here to get my correct digit. So 0, 1, 1, 0. Now add it. What will be your answer? Your answer will be, so your answer will be 1, 0, 0, sorry, 1, 1, 0, 0, 1, 0. Okay, your answer is this 1, 0, 0, 1, 0. Okay, now what you have to do? You have to take a combination of a 4-bit. So if you count this will be your 4-bit combination. So it will be representing your 2, and here you can add 0, 0, 0. It will going to represent your 1. So BCD, as we have got, the BCD stands for the binary coded decimal, and in binary coded decimal we have got a decimal symbols from 0 to 9. And for this, what we are using? We are using a 4-digit codes. 4 digit to represent this number. So let's say my code will start from 0, that is 0, 0, 0, 0, and let's say 1 will be 0, and then 9, like this. I'm not drawing anything. I will take only 9. What will be 9? This will be my 9. Now if I talk about the 10 will be your 8, 4, 2, 1, like this. Then after 10, what we have got? We have got A, we have got B, we have got C, we have got E. So how many additional we have got? Means with the 4-digit codes, if I am using this 4-digit code, okay, if I talk about the E will be your this. Till here you have understood? 10, A, B, C, D, E we have got. So how? But we are talking about only the decimal. Okay, we are only talking about the decimal. So when we are saying binary coded decimal, that means we will be using this one. So this will be our valid codes. This will be our valid code. And apart from this, we will be having our code. This will be invalid. This will be our invalid code. You got this concept? So first will be our 0 to 9 will be a valid code, and after 9 you are getting any answer 10, A, B, C, D, E. If a product of this is getting like this will be your invalid. That means if you are getting a 4-digit combination starting from 10, A, B, C, D and E, these any combination of either doing the addition or subtraction, you are getting it. So whatever the code you are getting which is lying starting from 10 to E will be your invalid. To make this invalid code to be a valid code, what I can do, you can see how many this is the 1, this is 2, this is 3, this is 4, this is 5, this is 6. How many additional we have got in a 4-digit code? How many addition we have got? 6. We will do a addition of 6. So let me take the same example which we have taken last time, or I can show you here. We have taken this 4 plus 5, okay, and this was the 9 result, and this was lying here, okay, this was lying here, okay. Now take the another example of 4 plus 8. 4 plus 8. What is 4 plus 8? 12. Okay, we should have to write a 4 plus 8 as a 12. But what we have to do? We have to write it in the form of a BCD. Okay, we have to write it in the form of a BCD code. So let's say if I write about 4, so what is the value of 4? Like this, and 8, and if you add this, what result you will get? You will get 1100. You will get 1100. What is this 1100 is coming to be? This is coming out to be 12. But what is happening? But we are not having 12 in our BCD code. Whenever we are getting this 12, what this 12 is, we will going to see that after 10 we have whatever the thing we are getting. 12 means this is 10, this is 11, this is 12. That means we are getting B. So what we are doing when we are using a BCD code, whenever we are using a BCD code, we are getting the answer 12. So answer 12 is an invalid code in terms of BCD. Okay, you are getting this point. This will be invalid code. You are getting a 12, so this is your invalid code. To remove this invalid code into a valid code, that is valid BCD code, what do you have to do? What do you have to add? You have to add 6. Or what is 6? 8, 4, 2, 1. So you have to add this 6 here. 0, 1, 1, 0. Now take out the answer. What will be the answer? 1, 0, 0, 1, 0. Okay? Everybody is getting this answer? 1, 0, 0, 1, 0. So we are getting 1, 0, 0, 1, 0. Okay? Now, as we have told you that the digit which we are writing is a combination of 4 digits. So what we have to do? We have to take this 4. So what it is representing? 2, and this 4. Let's say I can write here like this 0. What it is representing? 1, 2. Okay. So this will be your answer 12. So let me take another example. So let's say I want to add 8 plus 9. 8 plus 9. What will be 8 plus 9? 17. So check you are getting this answer 17 or not. CD means we are talking about the decimal only. Okay. So binary coded decimal. So because we have coded this, till here we are able to code it. But these bits are unused bits in a BCD. So whenever you are getting a resultant of this unused bit, you will be getting the error. To make that error to be corrected, what you have to do? You have to add, because these are the 6 terms you are getting addition. So you have to add 6 whatever to the result, whatever you are getting. So just do 8 plus 9 and see if you are getting the answer or not. All of you can do it. This 8 will be your 8, 4, 2, 1. And what is 9? 8. This, if I do the calculation of this will be 1, 0, 0, 0, 1. You will be getting this 1, 0, 0, 0, 1. So again, this will be your invalid, because this will give you how much? You can see you are not getting this 17 here. If you see, if you check this 4 code also here, this is not giving you 17. So what do you have to do? Okay, so it will be invalid code. You have to add 0, 1, 1, 0. So this will be 1, 1, 1, 0, 1. Now you can add any zeros here. And now you can see this will be your, and what is this? This is equal to 1, and this is 8, 4, 2, 1. This is equal to 7. So like this BCD code, we have got different types of codes also.
We are going to see that different types of codes in next lecture. I hope you have enjoyed the lecture. Thank you.